From Microbe TV, this is TWiP, This Week in Parasitism, episode 238, recorded on June 14th, 2024. I'm Daniel Griffin, and you are listening to the podcast about parasitism. And before I introduce people, I just want to ask our listeners, consider supporting the science shows of Microbe TV. You can do this in a couple ways. You can go to microbe.tv and click on the nice new contribute button, microbe.tv/contribute. You can go to parasiteswithoutborders.com and click on our big donate button. As I like to say, if you like what we do, if you don't like what we do, but you still want us to keep doing it, then click on there, send us some money. All right, well, let me introduce Dixon Despommier.
Well, good afternoon there, Daniel. I'm happy to be here. The weather outside, it's gotten very warm, but a couple of days ago, the weather was like early spring. It was crazy. It was like in the low 60s Fahrenheit. But today it's humid and hot and typical sunny.
I think we got some thunderstorms moving in, right?
Yeah, we do. That's a spoiler for you, I think. 'Cause
Well, it's going to be
you're a
okay
sailor.
because I got some racing in last night and we got a big distance race tomorrow
Oh,
morning.
good,
So
good, good.
I'm okay for tonight, but I want good wins for tomorrow.
Great.
And Dixon, where are you? You over there in Jersey where
I'm
everything's
living here
legal?
in Fort Lee, New Jersey, 1.5 blocks away by walking distance from New York City.
All right. And coming to us from Glasgow, Scotland, Christine Nalla.
Hello, everybody. Here in Glasgow, it is wintry, overcast, but otherwise quite pleasant.
All right. And we have a special guest, Mike Barrett, who now I know Mike, but I'm going to let Christina do a bit of an introduction before we ask Mike all about himself, including the all important question, what would you have done if they refused to let you become a scientist? So, Christina, who is this guy?
So let me introduce Mike. Mike is my colleague, Mike Barrett. I've worked with him for a long time now. I think I started off as a postdoc in his lab circa, 100 years ago. So Mike is a professor of biochemical parasitology at the University of Glasgow, and his research really focuses on understanding how drugs work against parasites and how parasites become resistant to drugs. So, we've got some fun discussions planned with Mike tonight.
All right, Mike, jump on in.
Excellent. Well, it's a great pleasure to be here. I'm a great fan of the show, and it's always been a dream to come on and speak to you guys. So, as Christina says, the weather here has been pretty awful this week up here in Scotland. It is still dark, and I've just seen Scotland losing 5-1 to Germany in the European Football Championships.
Sounds more like a nightmare.
Yeah, your dream and your nightmare. Oh my gosh.
I'm not even sure if the Swiss are in it this year.
I don't think so.
You don't think so? So I don't need to watch at all.
So, Mike, I know we're going to be talking about this paper, but before we jump into that, tell us a little bit about yourself. You know, we like to say the ID history. Where were you born? Where did you grow up? So, start at the beginning.
Okay, well, I was born in a new town called Harlow in Essex, which is just between London and Cambridge, and grew up there. It's a town that was built at the end of the Second World War, really to house the Londoners who had lost their homes during the Second World War. And from there, I went on to university, initially at University College in London to study zoology. And whilst I was there, I became very interested in parasites and went to the University of Cambridge to do a PhD with Dr. Richard LePage, who introduced me to the world of trypanosomes, upon which I've worked ever since. After Cambridge, I went to Bordeaux in France for a few years, still working on trypanosomes, before coming back to the London School of Hygiene and Tropical Medicine, working with Alan Fairlam, always on the biochemistry of trypanosomes and trying to figure out how to develop drugs to hit specific parts of their biochemistry. And after London, I moved to Glasgow, got my own lab here, and have been here ever since for probably 28 years now, I think.
So how did you end up? I always like, how did you end up in this? Your parents were like biochemical parasitologists. I'm assuming not. But what was-
Nope. Funnily enough, my parents actually were both journalists, largely in the sort of local newspaper world. My dad went on to become a lecturer of journalism at Harlow College and had famous alumni coming through, such as Mark Knopfler, the singer. Piers Morgan was another one of his students. He's a controversial British journalist. So, yeah, they both really worked on newspapers for many years when people still read newspapers.
I think now they read them, but on the computer, right? So it sort of misses the. I once shared this story. I had an uncle who was the guy who would yell, "Run the press," and so he was the guy at the basement of the New York Times who would, make sure everything was ready to go, and then you'd get like the actual that hot off the press. The papers were actually hot, right, when they were coming out.
Yeah, I remember going to see my dad's work sometimes and going to the press place there. And the printers would literally be putting these little lead letters into
Hmm.
blocks, which then would be bashed onto paper to create the newsprint. It was a incredible skill, I think, in the day.
You can thank Gutenberg for that one.
Yep.
That is true. But yeah,
You know,
what a
he
tremendous,
essentially revolutionized the rest of the world. After
yeah.
that, everybody could have a book, and
Mm.
so that's been an amazing advance. And I'm glad to see that some people still remember what that was like.
Yeah, but
I
the
often
poor
wonder
Irish
what.
monks, right? Putting them out of work.
Oh my goodness, right?
Well,
That's
actually, I did spend a fantastic 6 months working in Dublin, in Trinity College, in a
oh,
lab run by Paul Voorhuis, who's a fantastic chap at the time. First thing Paul did when I got to Trinity was to take me to see the Book of Kells, which is this amazing medieval illuminated manuscript which preceded Gutenberg, and it's what books perhaps should be.
That's
and the
fantastic.
Name of the Rose, which is one of my all-time favorite movies, with Sean Connery, was an amazing, I guess, illustration of what life was like prior to the popular press. This was the unpopular press.
Yeah, I know our media colleagues often get kind of beaten up, but it's a challenge. It's a challenge to communicate a lot of these complicated, ideas to folks out there. And in a way that, that engages, right? That keeps them interested, keeps them
Hmm.
reading. So,
Yeah. One of the difficulties, however, is that they never feed back what they've written about you once they interview you. If you've discovered something and you've had press inundated, how lucky you are. No, that's not luck. That's the nightmare of everybody's work, because it stops work and you have to take time out. And then they always get it wrong. Some parts of every story I've ever read about any of the thing I ever did was not
Mike,
correct.
defend the media for us, please.
Well, okay.
Talk about your parents.
No, I also do find that a challenge with the media is
Yeah,
not sharing with you
that's right.
what they've spoken to you about. But I've still got some friends in the media, and I think they do find it themselves a little bit irksome that perhaps in ways that they shouldn't, that people wish to. I think as scientists, we read and proofread and reread and
Oh,
fact checked
exactly,
everything we
exactly,
do, and I
exactly.
think sometimes a little bit too much proofreading can get in the way of a good story.
Wow.
Yeah.
Or that malaria virus.
Yes. Oh, yes. That's a recent one. I remember that. Ouch. So I see this paper that we're going to talk about. It's first author there. Is that any relationship? Is that
Which
Michael?
the
Michael
You,
Barrett. I'm
Mike,
Joe.
Michael B.
Michael
Barrett.
Barrett. It's
I know him.
You've met him before.
That's right.
So, well, before I let you talk about this, so Mike, before you get to talk about, this passion of yours, what would you have done if they would not allow you to become a scientist?
Other than a professional cricketer,
Okay, you can that is
it's
a
a
fine call. I have absolutely no idea what they're doing, but it does involve drinking a pee.
no, I I probably would have gone into journalism. I think I've always have had an interest in writing, and uh, I still do write when I get opportunities for
Absolutely.
magazines and sort of other forms of media. And it's always interested me how to string a series of words together in a way which can convey concepts in ways which make them comprehensible.
Right.
So,
All
Mike,
right.
maybe you could tell us a little bit how you became involved in that work that you're presenting here in this viewpoint article, which has been published in
Plus,
PLOS Neglected Tropical Diseases.
Yep.
So,
Okay. Well, it was actually the paper is more or less um, a resume of a World Health Organization meeting held more or less a year ago today in Geneva, discussing the elimination of human African trypanosomiasis, often known as sleeping sickness. And it's a very, very good story. And I think in otherwise fairly bleak days, the sleeping sickness elimination campaign has been remarkably successful. And I think that it can get more successful still. So, WHO invited stakeholders from around the world to Geneva to discuss how the elimination campaign is going. And yeah, it's something they've been doing. This is the fifth of the elimination uh, meetings that WHO have held since they really started going after human African trypanosomiasis as a credible target for elimination. And for the last um, 3 years, we've had fewer than 1,000 cases of sleeping sickness. It's kind of bottling or bottoming out a little bit at the moment, but there's still not too much concern about that because I think we always expected it to be a long process to get to the final few cases. Hence, ultimately, the title of this viewpoint is the elimination of human African trypanosomiasis, the long last mile. So WHO are extremely pleased with the way that things have gone. They have coordinated efforts. Ultimately, it's the national sleeping sickness control programs in the different endemic countries which do the work to actually go after the disease. But it has been incredibly well coordinated, really, throughout the 21st century. Thing with sleeping sickness is that it was known as the colonial disease before Europeans decided to colonize Africa. People had avoided the tsetse fly because it killed them or it killed their cattle. Um, Europeans came along and rather mixed up where people lived, and as a result, there were these huge epidemics of sleeping sickness in the early 20th century. And it took quite a long time for the authorities to get a handle on that again. Um, by the mid 20th century, actually, reversals of putting people into tsetse districts and the introduction of therapy, avoiding tsetse bites, meant that the disease was coming back down again. However, as the disease was coming down, efforts to control the disease stopped. And as a consequence, at the late part of the 20th century, sleeping sickness was on its way back. And by the turn of the century, it was estimated that there were in the order of 300,000 sleeping sickness patients, which was kind of crazy because here was a disease that we had drugs, we knew how to avoid getting the disease, and yet it was beginning to run rampant again. And that's when WHO really decided they had to do something. And at the same time, Médecins Sans Frontières, who had been doing a lot of the work in setting up clinics, field hospitals to deal with the epidemics, realized that the situation with drugs was pretty appalling for sleeping sickness. The main drug used once the parasites had gotten into the central nervous system at the late 20th century was melarsoprol, this terrible arsenic-based drug which kills 1 in 20 people who take the drug, irrespective of whether they got the parasite or not. You have to inject it. I think there was a famous British journalist who described that injection as being akin to having chili peppers injected into your heart. So Médecins Sans Frontières were very keen on getting better drugs out there. And it was very difficult to do that because the pharmaceutical industry were not terribly interested in making drugs to treat the world's least prosperous people. And there's a very famous story, which I don't know if you've covered here.
We have not, and I was going to say, Mike, tell us the story.
Aflornithine,
Yes.
difluoromethylornithine, was a drug that had been developed to test against cancer. DFMO, aflornithine, is a compound which inhibits the polyamine pathway, which is known to be elevated in various cancers. Well, there's a chap called Cy Backey in New York in the 70s, and Cy was interested in polyamine metabolism in trypanosomes. So he got hold of some DFMO, and he found that it would kill the parasites. He then found it would kill the parasites in mice, and then Simon van Nieuwenhoven and some others in East Africa at the time did a few clinical trials which probably wouldn't cut mustard with regulatory authorities today. However, they managed to show that they could cure patients of sleeping sickness using eflornithine, and the drug got registered. Trouble is, it was pretty expensive to make, and it never made it as a cancer drug, although actually last year it has finally made it to treat some rare forms of leukemia. But as it never made it as a cancer drug, it was only useful against sleeping sickness, which afflicted exclusively the world's poorest people. Nobody was prepared to produce it. WHO were trying desperately to find manufacturers. Nobody would do it. However, in the meantime, that cancer work had gone on to look to see whether DFMO could cure skin cancer. And in some pretty gruesome experiments, mice were taken, the hair was shaved off of their backs, chemicals were applied to induce skin cancer, DFMO was added topically, and it didn't cure the cancer. However, the hair didn't grow back on the mice while the drug was being given. Somebody then had the idea that a compound which you add topically and prevents the growth of hair might have a use, and it was tested to see if it would prevent the growth of unwanted facial hair in women who found the growth of unwanted facial hair embarrassing and I think socially challenging. And suddenly you had this compound that nobody was prepared to make to save lives. And drugs companies began to compete with one another to produce this drug or to get hold of eflornithine to market it for the treatment, for want of a better word, of unwanted facial hair. And that was a real watershed moment because nobody could really see that that was a very good thing, that you'd want to make a drug for facial hair and you wouldn't want to make a drug to save lives. However, it also crystallized, I think, one of the main issues with the pharmaceutical industry. It's not a charity, it's an industry. It needs to make money. That's what it's actually there for, not to make drugs to save lives. And I think that particular example really let everybody know that that's what the situation was. And no matter how bad it is, that was the reality. And that's when Médecins Sans Frontières really decided they had to do something a little bit different. So they span out and founded the Drugs for Neglected Diseases Initiative, DNDI, specifically to look for new models to enable drugs to be developed for neglected diseases like sleeping sickness. And DNDI found it pretty easy, I think, to get money to start with. They had a lot of charitable money coming in, philanthropy money coming in. The pharmaceutical industry themselves also were pretty uncomfortable with the eflornithine story because it really let them know what their fundamental reason was all about. And actually, lots of pharmaceutical companies were prepared to join in this uh, campaign to look at ways where they could use their resources to help people to make drugs against neglected diseases without having to take some of the financial risks that would be making that impossible for them. As a consequence, well, the first thing is that WHO managed to get Aventis at the time, who's now Sanofi, to produce eflornithine for free and give that to patients for sleeping sickness. Sanofi then began also to give their other sleeping sickness drugs to WHO to distribute for free. Bayer, who made Suramin, another one of the sleeping sickness drugs, they decided they would do the same. It was later shown that eflornithine worked even better if you made a combination with nifurtimox. It was just an old Chagas disease drug. And Bayer also gave that away for free to use with Sanofi's eflornithine. So you've got these two potentially competitive drugs companies, both providing compounds for free. So the nifurtimox eflornithine combination therapy was fantastic. For most sleeping sickness patients, you didn't have to give the horrible arsenical anymore. In the meantime, the Drugs for Neglected Diseases Initiative began a campaign of looking for new compounds. And amongst those new compounds, they came across a compound called fexinidazole. It's an old nitroheterocycle that Frank Jennings here in Glasgow had first shown to be efficacious against trypanosomes. It's an old Hirsch compound. Frank actually dropped it because as a nitroheterocycle, a lot of people thought it was going to be generically genotoxic and not further developable. DNDI picked it up, and they didn't believe that you couldn't develop a drug just because it belonged to a particular class. They believed that you should do the experiments, and it turned out the fexinidazole wasn't genotoxic in the way that had been feared. It's already available. They've developed it. Fexinidazole can be given orally over 10 days and will cure both stage 1 before parasites have gotten into the brain and stage 2 sleeping sickness. So fexinidazole has been licensed or has been approved by the European Medicines Agency since 2018. It's been used for gambiense disease. There are two forms of sleeping sickness, gambiense West and Central Africa, rhodesiense in Eastern and Southern Africa. 2018, fexinidazole got a positive opinion from EMA for gambiense disease. And just this year, WHO has written new guidelines based on DNDI trials that also for rhodesiense disease it can be used. So we're now in a situation where instead of having to decide if you've got rhodesiense or gambiense, is it stage 1 in the blood, stage 2 in the brain, and have different drugs, complicated drugs, toxic drugs for all of those different conditions, we're now in a position where we can give an oral drug for all 4 of those types of sleeping sickness, other than in exceptional cases, such as in juveniles or in people of less than 20 kilograms. So the situation with chemotherapy for sleeping sickness has changed massively just in the last few years. And even before that change in the chemotherapy, decent surveillance programs, those free drug campaigns, the distribution of drugs had meant that the disease has been coming down even before the new therapies become available. Better news still, the DNDi drug searching campaigns also came across a series of compounds called benzoxyborols that were being developed by initially Anacor Pharmaceuticals. Synexis, a biotech down in North Carolina, picked them up. And amongst the compounds that they developed, one called acoziborol is orally available and will cure stage 1 and stage 2 sleeping sickness with a single dose. So we've gone from a situation where you've got stage 2 sleeping sickness, you're going to have to do a horrible diagnosis with a lumbar puncture. You're going to have to then potentially give people a very toxic arsenic-based drug and do multiple lumbar punctures to check whether they've cured or not afterwards. Potentially now we're in a situation where you can, without having to do a lumbar puncture, if somebody's got even a serological test for sleeping sickness, you can give them a very safe oral drug in a single dose and cure them. There's just a little bit of extra work to do, I think, to get acoziborol into the manufacture process ready to go, but it's past the trials, it's ready to go. So it's extraordinary, I think, compared to what sleeping sickness was like when I first started working on it, to what we can do now. It's the transformation's been incredible. And I think partly because of that, and because of the excitement that people have figured out how to do the surveillance campaigns, diagnostics have improved, and even where diagnostics remain imperfect, we're even reaching a point where we can see that you may even contemplate just going into a region. If there's any suspicion of trypanosomiasis in a village, you've got a drug that's so safe, orally available in a single shot, single oral dose, just give it to everybody in the village. So test and treat campaigns could become available for human African trypanosomiasis, and I think there's a really good opportunity to eliminate this disease once and for all.
What's the expense for that drug?
It's not hugely expensive. I think the chemistry is pretty good, and it's not, eflornithine's pretty expensive because it's very difficult to make. Acoziborol is less difficult to make, and at the moment the plans to make it are all specifically for sleeping sickness, and say Sanofi remains committed to help DNDi to produce it. So I think its actual cost for health systems to use is going to be free. Um, I guess what we do need to be a little bit conscious of, though, is that a lot of what's happened in the last 20 years has been because there's been an attitude of philanthropy. We've seen that the sleeping sickness drugs have been given away for free. We know for a lot of other diseases, drugs have been given away for free. We know that Bill Gates has put a lot of money into the development processes. There's been organizations willing and able to take that money to do those development programs. I guess the thing that worries me now isn't so much the science, it's the socioeconomic climate into which we appear to be moving. All of these things can happen, and yet we're in a position where, who knows if drugs companies who give drugs away for free for WHO to distribute say we're not going to do that anymore. And who knows what happens if the governments of the world decide that they don't want to pay their dues to United Nations organizations like the World Health Organization, and what might happen to those campaigns then. So I think the science is there, and we just have to be very cautious of the socioeconomics to make sure we can deliver on the achievable goals now.
So a lot of optimism here. This is great stuff. I want to
Absolutely.
make sure our listeners who maybe are not all up to speed. We have sort of a range of listeners from people like you, Mike, all the way to the gardener in Minnesota or the surfer in Australia who like to listen. So maybe we should give just maybe sort of an introduction to the disease so people understand it, because there's a lot of like specific issues that I'm hoping we could talk about. So for an overview, should we let Dixon and Christina, do you guys want to sort of tag team? How do you get this thing? How do you get this
Christina, it's all
disease?
yours.
It's all me.
I did my
So
work on worms, remember?
I suppose I did do my PhD in trypanosomes, although not a human infective species or subspecies. I worked with Trypanosoma brucei, but I think I can probably manage the life cycle. So trypanosomes, they are kind of small single-cell protozoan parasites. They are transmitted by the vector, the tsetse fly, and actually maybe Mike, later we can talk a little bit about the tsetse fly as well, because you kind of cover it in your article as well. I think it would be quite interesting to talk about that. So the tsetse fly would be taking blood meals from any kind of mammal, really. They do, some of them prefer animals, others maybe have a preference for a human host, but they do need blood meals. And actually, when we talk about mosquito-borne infections, we always kind of say that it's only the females that take blood meals, but actually with tsetse flies, both male and female flies do feed on blood. And I did read I don't know, it was just coincidentally this afternoon, I was looking through the literature a little bit because I wanted to look at kind of infection rates of tsetse flies. How many tsetse flies do you actually have trypanosomes in them? So I came across a paper that was looking at animal trypanosomes, so not species that are infectious for people, but you kind of they did discover in one region in Kenya about a 5% infection rate, which I'm not really sure because I don't really have much to compare it to. I don't know if that's a lot or if that's a little, but going back to the males and females, so it was great. Even though actually both take blood meals, there was a preponderance of females being infected with trypanosomes. Now, I don't know whether it's specific to this particular study or maybe this particular species, but I think that would be something interesting to maybe further look into.
It is fascinating, right? Though, I mean,
Mm,
this is sort of maybe an important. I don't know if anyone has to take an exam at any point, but the whole concept. This is different than like malaria and the female who just needs the blood meal for egg production. Male and female tsetse flies take blood meals, and both male and female tsetse flies can actually become trypanosome infected and transmitters, right? So that's
Yeah. It's even more fascinating when you look at how the tsetse fly lays its eggs, which it doesn't. It lays a live larva, which it has fed from a teat-like organ inside. It feeds it with its mother's milk, so it
yeah,
gives
they're
birth to
basically mammals.
one egg, one larva per day. It's a very low reproduction rate compared to most other um, vectors that we know about. So I didn't mean to
yeah,
interject, but that's the
yeah,
one factoid I could
yeah.
offer here.
No, that is really interesting. And I think they produce about one larva every 10 days or so. So really, really slow. So I think that's probably why some of the vector control efforts were quite successful because there weren't millions. And I think they're also quite easy.
Except in West Africa, isn't there millions?
I don't know really.
No, I think
Um,
there is. I think the riverine variety of of the
The
tsetses is
tsetse,
very
yeah.
dense, and
That's
you can
that's a big difference, right? Is so the eastern, I think it's what, like one
one
tsetse
per
fly
square
per
mile.
square
Yeah,
mile. Yeah,
okay.
exactly,
so a
exactly.
large, where in the west you have this much more dense. So that's actually probably going to play a part in vector control. It always sort of troubles me. I don't mind they wipe all the mosquitoes off the planet, but the tsetse fly sort of has a special place in my heart. I mean, what a wonderful
No pun
organism.
intended.
Well, yes. Yeah, we're not talking about Chagas today, but
Well,
yes, good pickup on the.
my wife and I were on a tour of Africa, Central Africa in this case. So it was Zambia, no, it was Zimbabwe, Botswana, and another country which I'm blocking on right now, but it's in that same area. We were in Zimbabwe, in the world's second largest animal preserve in Africa. And the reason why is because it's loaded with tsetse flies. I mean, the tsetse flies were everywhere. And the guides were saying, well, we haven't had a human case of sleeping sickness in 3 years. These are all feeding on animals, and they have no interest whatsoever in people. And I saw some in the cars and in the boats that we were in. I was really put off, and everybody else was saying, "Why are you going in so upset?" I said, "Because I'm a parasitologist and I know what I'm looking at, and I'm looking at a tsetse fly, and I don't want them." And they said, "Oh, show us." And I said, "It's the one with the little hands in the front of the fly. If you see a fly like that, stay away from it or smack it and get rid of it."
It does have an
So
impressive
Christina,
proboscis.
we get bit
Yeah,
by these
let's
wonderful
go back to
tsetse
the life
flies.
Yeah,
cycle.
no,
Yeah,
no, Christina, I'm very good at diverting
that's
the
okay.
subject matter.
I think I started diverting. I got distracted myself. So the when the blood meal's taken, the trypanosomes get injected, and they live in the blood, so they're not intracellular parasites like, for example, malaria or leishmania. Actually, they are quite closely related to leishmania. They're also closely related to Trypanosoma cruzi, which causes Chagas disease, and they have an intracellular stage in the human host. But the African trypanosomes, they do live in the blood exclusively, and they multiply by binary fission, which is really quite amazing to watch actually under a microscope. I don't know, I'd never really, when you look at them, you don't expect them to divide by binary fission somehow. I don't really know how. I imagine they would divide, but it does look weird. Um, if you ever have an opportunity to look at the slide. So they do circulate, and I'm not going to, I think, Daniel, I'm going to leave the clinical stuff to you. So I'm going to go back to the next blood meal of a tsetse fly. So the tsetse fly comes and feeds again, or it's probably another one. Well, it's almost certainly another one. And the trypanosome will be taken up. And I think actually it's a form. So there's two different kind of forms of bloodstream trypanosomes, the long slender ones and the short stumpy ones. And I think it's
Mhm.
the short stumpy ones that are infectious for the tsetse fly. Mike, am I correct?
You are.
Wow, thank goodness. Um, it's always easy to mix these things up. So in the tsetse fly, they actually undergo quite a complicated differentiation process um, before they eventually migrate back to the salivary glands and become infectious metacyclic trypamastigotes again. And that kind of closes the cycle. So
Yeah, no,
Daniel,
that
tell us
yeah.
about a disease. What happens when these
Yeah, so
trypanosomes swim about in the blood?
so clinically, right? So um clinically, like how is this described? What are people? So one thing, and and this is true most of the time, is a tsetse fly bite really hurts, right? I say most of the time, right? Because you look at the literature. I was taught it always hurts. I wonder who taught me that. But sometimes you look at the literature, people don't necessarily feel that, but most of the time it is painful. Ouch! And then an actual a chancre is really like a wound that develops at the site of the bite. So that's sort of this initial. And then there's a little bit of a distinction, I should say, between West African and East African, right? So West African, sort of this more insidious, and we remember Winterbottom sign. I think we attribute that to one of the Scots, Dr. Winterbottom, who spent some time in Africa. And we don't want to disparage him because I think he was actually a person who's really opposed to all the slave trade, which is actually the source of the economic boom of Scotland, dare I say. And he, I see Mike nod his head back and forth, but and so
Hey, he's from Britain. He's not from Scotland.
he's okay. And Christina's from Switzerland, so where's the Scot defending? But you actually can develop these large swellings in the back of the neck called winter bottom signs. That's another sort of one of the things that we think of as West African. East African, actually, there's a little bit more of a rapidity in sort of the clinical disease. So the infection can rapidly progress with East African, really sort of a 2 to 3 weeks. And then maybe 3 to 4 weeks after infection, you're already seeing CNS disease in East African. Where in contrast, right, the West African, it might take months and even years perhaps to get involved in the brain. So that was sort of, and how do our listeners remember this, right? So think about West African, Dr. Winterbottom. Why is he describing this sign? Because there was a concern that the people engaged in the slave trade at that time would end up bringing someone aboard who seemed fine at the moment, but would then progress, and they spend all this time and effort, and now they have this individual who's gotten sick over time. So sort of a difference in these two. And I think clinically is going to be a big thing we'll circle back to when we get Mike to talk more about treatment here, is this making this distinction between early and late disease. So early disease where you're jumping in, well, historically with a certain type of treatment, and then late disease where you're actually doing lumbar punctures, determining if there's CNS involvement, because then you're going to be suggesting different treatments. And sort of, reading your article earlier today, Mike, as I was Ubering to get my broken car back from the dealer, just the thing that really stood out to me is that Millarciprol kills up to 5% of patients. So you got 20 patients in front of you. You're going to try to treat them. You're going to kill one of them. I mean, and as a clinician, that's daunting. And there actually have been some stories, right, where you've killed someone who was like the son of one of the tribal leaders. And this is not a good way to create a relationship going forward to treat these people. And, and seeing, a lot of the places where this disease would affect people, this isn't like a nice modern Western facility. This is someone sitting on a stool getting a lumbar puncture in a village, right? I mean, this was just a tremendous challenge when you put all this in.
Yeah, I think the horrors of Millarciprol were one of the main motivations for a lot of the Médecins Sans Frontières people to really push to get something different, because it was so traumatic. You just imagine a young physician who's gone out to Africa and is getting involved in some of these epidemic situations, and they got a drug and they know that they're going to kill 1 in 20 people into whom they put this drug. Many of the others get other pretty unpleasant side effects and neurological symptoms. And there were many stories of physicians who gave up because they just couldn't really take having to put this poison into people. So the transformation with the new therapies now is fantastic, I think, for many people.
Yeah, I still remember taking an exam. This was many years ago. I was in Tamil Nadu, southern India, and why am I learning about treatment of African trypanosomiasis in a place like that, right? Wrong, sort of the wrong spot. But one of the test questions was, and it was, you had to have memorized for this test what were the different preferred treatments for early stage trypanosoma gambiense versus East African, and I clicked through, and then I was like, that's unfair. Nobody should have all this memorized. Not only should you be looking it up, but and it used to be the treatment was pentamidine, right? Which here in the U.S. we would never give that to someone without like EKG monitoring. There's electrolyte disturbances. There's arrhythmias that are triggered. You're giving it IV over a couple hours or a very painful IM shot. You're doing that for like a week, right? That was your early stage West African treatment. Yeah, and then maybe you're moving on to suramin, right, for your either alternative or, if you're concerned about, late stages. Uh, but Millarciprol, horrible. But yeah, really this great step now, the idea that you can use oral therapy and maybe one dose oral therapy, because the challenge always was you had to be so certain of the diagnosis because you might kill somebody.
Exactly. Yep.
We actually have a lecturer on the DTMH who gave a really, really good tutorial about African sleeping sickness, kind of clinical presentation. And something that she said is, you really have to earn Millarciprol. You don't just give it. And actually, I don't know if you remember, it was in TWiP 235. We talked about Ernst Friedheim as a hero. He was the guy who developed Millarciprol, and I remember from there that actually this drug is not even water soluble, which probably adds to its toxicity. So it's dissolved in propylene glycol, and that also, induces even at the injection site a really severe um, inflammatory reaction. And then, of course, it's also an arsenical, which, well, I'm just thinking about arsenics and lace, that Agatha Christie story. You know,
Yeah.
Well,
yeah,
Millarciprol took over from a previous
from an even worse
arsenical
drug.
called
Yeah,
trypanosomide, which
yeah.
made
Yeah, right.
hundreds of people blind.
Mm.
Um, and trypanosomide came from a development program, the pinnacle of which was atoxyl, which was called atoxyl because it was considered atoxic. And that's because it actually was extremely toxic, but its predecessor, which gave people some hope, was another arsenical that did kill mice, but the mice were cured of sleeping sickness when they died. So that was, there's this incremental improvement in the arsenicals got as far as Millarciprol, and they were pretty pleased with it then. And it was, we'll talk about later, Dr. Livingstone who first put arsenic into a trypanosome infected horse, and he used arsenic trioxide and got a temporary cure. And that was actually the stimulus for uh, chemists in the late 19th century to begin to play further with
Mm,
arsenic, which then Paul Ehrlich went on to play with and
right.
produced salvarsan to cure syphilis, and also got the arsenicals into trypanosomes. And then we saw
Yeah,
that
yeah.
that progression to Millarciprol, which hopefully we will see no longer in a few years' time.
So, Christina, you didn't mention why we haven't got vaccines against the trypanosomes.
Uh, yes.
Would you
So,
please talk about
yes, I can try. Oh. Yeah, so
well,
trypanosomes, they actually have this really amazing ability to change their surface coat, their outside. So they are the immune system does recognize the trypanosome very, very well, and it very quickly eliminates the trypanosomes from the circulation. But the trypanosomes, they have yeah, a vast, vast repertoire of genes. I think it's probably around, is it maybe about 2,000? I may be overstating that a little. I'm
It's
not
about
sure.
1,000.
Yeah, 1,000. Don't, don't hang me out to dry on the number. Um, but,
more than enough.
plenty. So every now and then, a single trypanosome that will switch to transcribe, and then a different of these variant surface glycoprotein coat genes, and the trypanosome will have a different coat, and they can then multiply and replicate really rapidly again in the blood, and then the immune system comes in again, and the process can continue, I suppose, until the patient is too ill, maybe dies. So that, yeah, that's why, and well, that really makes it very, very difficult to develop a vaccine. That coat is also very, very dense. So the trypanosomes do have
Mm.
other proteins on the surface as well, but they're not very accessible to the immune system. So the main immune response to trypanosomes is really against that variant surface glycoprotein, and not against what's underneath. So I suppose, yeah,
Yeah, we
that
did
what
a
makes it
I
really
remember doing
difficult.
TWiP on the VSG, the molecular mechanism
Mhm,
behind that shifting.
mhm.
Yeah.
Uh,
And I think we did also do a paper about a vaccine development for Trypanosoma brucei congolense
Yes,
a while ago. So
So
that's right.
it's T-Vivax from
T-Vivax,
Vivax.
yes.
Gavin Wright. Yeah.
Yes, yeah.
That's the sexually transmitted trypanosome, right?
No,
Isn't T-Vax I?
Vivax is
Not,
transmitted sometimes by Tsetse flies, but also by non-Tsetse biting flies.
what's the
Um,
sexual transmitter? Evans I
that's
or
equiperdum. Is
Equipur?
yeah, in
Right,
horses. Yeah.
indeed. So why is it called sleeping sickness? Why do they go to sleep?
I guess, Mike, I'm going to let you take
Yep.
that one.
It's so the parasites, they get into your bloodstream and lymphatics from the Tsetse bite and proliferate there for a while. And then rhodesiense within a few weeks to a few months will get into the central nervous system. Gambiense does the same but takes a few years to get there. Once the parasites are proliferating within the central nervous system, including the brain, they cause a number of different neurological symptoms, one of which is a complete disruption of sleep wake patterns. And actually, sleeping sickness patients may not necessarily sleep any more than anybody else. It's just they've got no control over when they sleep. And when the clinicians were beginning to look at these cases, often their patients would be asleep during the day. Hence, they would call it sleeping sickness. But those same patients may be up all night. So it's really one of the manifestations of the neurological breakdown of human African trypanosomiasis that involves those sleep-wake patterns that led to its being called sleeping sickness.
Do we know the biochemical mechanism that's
Nope.
specific? A lot of
Uh,
speculation involved tryptophan, as I recall.
well, actually, so we did um, a few years ago a metabolomics study looking at CSF from stage 2
Mhm.
sleeping sickness patients, and we found very high increases in kynurenine, which is a immunologically related metabolite that comes from the tryptophan pathway.
Okay.
Um, 5-hydroxytryptophan is greatly elevated, and serotonin, I think. So it does look as if there's a lot happening to the tryptophan pathway in the brains of people infected with trypanosomes. So it may well have something to do with that, but it's been very difficult to definitively. Well, I guess just doing those experiments is pretty tough.
So animals don't get the same syndrome as humans in that sense?
They can, but although it tends to be less chronic. So so for example in
Mm,
mice we do have a model for stage 2 disease where we've got particular trypanosomes which will get into the CSF. And they've been fundamentally important in enabling the screening of compounds to
right.
make sure we can get drugs across the blood-brain barrier to cure the parasites in the brain. Um, but the pathology isn't really quite the same as it is in humans,
Right.
although the parasites are in there. But I think what's happening biochemically doesn't necessarily reflect what we see in humans.
So I meant to also, when I asked, did any work that came out of ILRAD contribute to the current status of control for trypanosomiasis? Because I was there almost the day it opened, a long time ago, I might add. And it was quite exciting to be there. And everyone was very hopeful that they would have at least a cure for the cattle form of the disease, but I don't know what happened.
No, it's so the days of Ross Gray and some of
Yeah,
our
yeah, yep,
other
yep, yep, yep.
Glaswegian colleagues.
Indeed, indeed.
Yeah, so I think a lot of great basic
Sam Black
research was
also.
done.
Yeah.
Sam
Hmm.
Black, and I think a lot of the effort went into doing things like looking for trypano-tolerant cattle.
Yeah,
So they never really went down the drug pathway.
right.
But I think some great work was done in figuring out the kinds of cattle that you might be able to prosperously farm within trypanosomiasis regions because they're tolerant to the parasites. There has been progress in drugs for veterinary trypanosomiasis in recent years. There's an organization called the Global Alliance for um, Livestock and Veterinary Medicine, GalvMed, which is somewhat like the Drugs for Neglected Diseases Initiative and their aims for humans. GalvMed has taken on looking at various neglected diseases of animals, and they've had a trypanosomiasis campaign, and they've hooked up with Boehringer Ingelheim, and they've had significant investment from Gates and the UK government in particular, and they seem to have some compounds which are looking pretty good for veterinary trypanosomiasis as well coming through.
Has anybody considered what would happen if indeed you had a wonderful drug for trypanosomiasis in cattle, and then cattle invaded the Serengeti?
hmm
Is it the ecological consequences of that would be disastrous for the wildlife?
Yep. And I think one has to hope that the protections which are put in place for the wildlife
Uh,
preserves in particular will be robust. But actually, what you already see around Africa, if you take some satellite shots, you'll find that farmers increasingly are moving their cattle to the edge of the game reserves. And sometimes, because the game reserves don't have big fences around them, those cattle can go and find some nice pasture within the game reserves. So I think it is a risk, and I think it's all we again it's where socioeconomics is our biggest threat as the
right.
science enables us to do things. But one hopes that measures can remain in place to
Yeah,
uh, preserve those game reserves. I think especially now that many nations do look at the game reserves as a huge resource for their own economic prosperity as well as
absolutely.
uh, looking after the environment.
I always looked at nature having a patrol of lions that would prevent the invasion of cattle simply by eating them, but that's, you could overwhelm those systems, obviously. And I think the Maasai do very well at keeping lions away from their cattle.
hmm
Even though their weapons are quite primitive, they're really useful. And I was always impressed with how people could get along if they really wanted to in those situations. And I think the indigenous populations of East Africa, at least, have done a wonderful job of trying to live in harmony with the elephants and the other
hmm
invaders of their crops. But then I heard that they were trying to domesticate eland. And I don't know whatever happened to that one, but that was an interesting thought.
Yep, I don't know what happened to that one.
That probably bombed as well as 800,000 other ideas. But it's had a rich history of trypanosomiasis is a romantic subject almost in terms of its history and brucei and Bruce and all the other. Yeah, but you were going to say something about Livingston. I'm sorry, I didn't mean to step on
Well,
any of your stories.
before we move to Livingstone, I just to kind of get us to modern times. So, Chuck Kinnersa and I were talking quite a bit about this the last time we were together at one of the ASTM&A conferences, and so fexinidazole needs a catchier name, but that's okay. Um, Maybe if it gets a catchier name, they'll charge more. But so this is great. It's oral. You take it. It's funny. You complain in your article. I'm going to say you have to, complicated. Got to co-administer with food. I'm
hmm
like, oh, this is so easy from where we're coming from with everything else. But okay, so you're taking it with food. Great for West African. You feel like we're kind of there with East African as
We are
well.
there. Yep, it's there.
Okay.
And say just early this year, WHO has rewritten the guidelines, which are going through the administrative processes within WHO. But we are shortly going to have the formal guidelines. Stage 1, gambiense, fexinidazole. Stage 2, gambiense, fexinidazole. Stage 1, rhodesiense, fexinidazole. Stage 2, rhodesiense, fexinidazole, other than in rare, complicated cases. So
Okay.
the simplification has been terrific. But because of those complications, the 10 days, taking food, some gastrointestinal problems, it's the day that acoziborole comes, I think, to replace that is just going to be another step change in the treatment of sleeping sickness.
So
Did you say
you,
that was a one single
one pill,
tablet
one
thing?
Two tablets,
Two.
but given together at a
pills.
single time
Okay. So
as an
So
you
in
said,
outpatient.
West
yeah.
Africa, you still have the absence of reservoir hosts for the most part.
They,
But
s-
in
i-
East
i-
Africa,
yeah, and
what do you that it it still looks like a vaccine might still be more effective if you had one than having to give pills every time an outbreak occurs.
and it's the thing that worries me about rhodesiense is that the the parasites can live in a wide range
Yeah,
of animals, not just cattle, but
yeah,
rodents and
absolutely.
elens and whoever.
Sure.
Um, I also fear that brucei, which is not human infectious because we have
Right.
uh, innate immune mechanisms which will kill
Mhm.
all trypanosomes other than the gambiense and rhodesiense types. But the way that rhodesiense we know became infectious to humans, it was just a brucei which couldn't infect humans. And the 1,000 or so VSG genes, that variant surface glycoprotein genes that Christina alluded to earlier, is at some point one of those mutated in a way where it could bind to and prevent the activity of apoprotein L1, which is a trypanosome lytic factor. And then by Darwinian evolution, you've got this clear sort of
Yeah.
mutation, which would normally have gone nowhere, but just happened to be able to prevent trypanolytic factors killing the trypanosomes. And bang, you now had a new
Right.
species that could
Right.
cause infections in humans. And my guess is that similar mutations could come along in the future. So we could get rid of rhodesiense,
Hmm.
even in
Hmm.
animals, and then bang, the 3rd of June 2058, a mutation happens again and we can take off again.
Mm.
Any ecological data on how long ago that happened?
Most likely, not much more than 100 years ago. It seems it was
That's
probably
all.
a
Oh
for
my.
rhodesiense. And again, that's just looking at the genetic sequences of the
Mm.
rhodesiense strains which have been found and sequenced, and compare those to the brucei, and then sort of use genetic um, histories to
Wow.
try and figure out what the evolutionary rate has been.
My goodness.
Some people used to think that it may have been Henry Morton Stanley, Livingstone's uh, colleague, who
Was
bought
the
trypanosomes
case
from West or East
zero?
Africa. As it's probably, see, he marched from West to East Africa,
Mhm.
and it was about the time he arrived in East Africa that the first rhodesiense epidemics
I'll be damned.
initiated. So historically there was something behind that, but but the reality is, if you look at the genetics of the West African gambiense and the East African
Yeah.
rhodesiense, they are
Yeah. Yeah.
there's no way that it was a transfer. It was
Right.
an evolution of a new thing. So that nice historical idea didn't really pan out.
Right. And the vectors, of course, had to be considered too, right? Because they're different for both
Uh,
East and West African trypanosomiasis. So
yeah.
yeah, so very complicated system. Very
Hmm.
complicated. I admire anyone who stays in it for more than 5 years. Really. I knew Lex Vanderplug pretty well while I was at
Ah,
Columbia, and all of his followers, and he came from Pete Borst's lab, I
hmm.
guess, in Holland. And I heard so much about trypanosomiasis while I was um, working on my little worm that I wish I had worked on trypanosomes, but I'm in the long run, I'm glad I didn't.
Uh,
I mean,
But
one of the things you mentioned in your article, Mike, which it has me concerned, is this. As you get down to so few cases, from the clinical standpoint, like who are going to be your expert clinicians if you don't see sleeping sickness? So if you don't see the disease, in what way are you a clinical expert? So, I worry when we get to this last mile and the numbers go down. I mean, I've seen people give lectures like talking about, East African sleeping sickness and then saying, but I haven't seen a case.
Hmm.
And it's kind of hard. And I think that you run into this weird issue. The numbers are low enough that we're going to lose clinical expertise. The numbers are low enough that how are you going to convince someone to come up with a vaccine? I mean, people put their money and efforts towards things that they perceive as the problem. So how do you get over the line?
And it's a real worry because I think we've never been this close before, but in the sort of 1970s, the numbers came right down. And that's exactly what happened is that, how can you possibly, if you're in a country which has got sort of hundreds of thousands of cases of malaria and HIV took off in the 80s and 90s. So when you're competing for a incredibly small pot of money in any local health system, it's very difficult for the sleeping sickness campaign to say we need a big chunk of the pot just to survey to make sure we still don't have any cases. So I think that's again, it's the socioeconomics which may confound our ability to hit this target rather than what we can do scientifically now. WHO remain really on top of this, and I think they, with the historical facts about having gotten close before and not quite made it because the interest waned, they're really still pushing hard to maintain that. For example, in September, they're having they having, I think, their fifth or sixth sleeping sickness school where they bring clinicians from all over Africa to really learn about the diagnostics and treatment specifically of sleeping sickness. They're really promoting the maintenance of those campaigns within the countries. They'll continue to look to see if there are alternative external sources of funding to help maintain the programs if local countries can't do it themselves. But yeah, it's a real problem, and I think it's probably a test case here that of I think at the moment guinea worm we're down to about
Mhm.
13, 17 cases or whatever.
Wow.
Hmm.
But then dogs have come along and carry guinea worm, which may
That's right.
confound that.
That's right.
Polio has been very, very close, but keeps bouncing back. I wonder whether ultimately sleeping sickness could be the first disease for humans since smallpox that we can get, and maybe that's the sort of badge to use to try to retain the level of interest that's required to see if we can get there as an exemplar for
That'd be
how other
wonderful.
diseases can go.
The question also um, regarding cattle again, but people live where their cattle can survive. They don't care about themselves too much, as I remember hearing about that. But do those drugs that work against human trypanosomiasis also work against cattle trypanosomiasis?
They probably do to some extent, but we're quite careful not to use the same drugs for the animals as humans, primarily because the regulation about how we give drugs to animals isn't as tight as it is on how we give drugs to humans. So if we were beginning to put the same compounds into cattle en masse, the chances of selecting
But
parasites resistant, which will
of
then
course,
subsequently get into humans, is
but
is
of
too big a
course,
risk.
but of course.
So there's a lot of thought goes into sort of trying to keep that barrier um, between the compounds used for.
The people that developed ivermectin, um, I'm not going to go there. Okay, fine, we'll change the subject.
Yeah, yeah. So you were going to tell us about Livingstone.
Oh yeah, 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 yeah. I want to hear. I definitely want to hear.
No,
Yes,
I guess before we go there, any other things we should be talking about here? I mean, I think one last thing I wanted to make sure to talk about was, the diagnosis, right? So I think Christina had the quotation that you have to earn your Millarciprol. But as the numbers go down and your pretest probability goes down, the card agglutination test, so the CAT, even if you have a positive test and your pretest probably, you can end up with a lot of false positives.
Mhm.
So we're sort of, I feel like we're in a good spot with the newer drugs where you don't want to kill 1 in 20 people and it turns out half the people that you're treating don't actually have it. So I'm happy that we've got, better drugs, but we probably need, you mentioned simplified lateral flow tests, but they're going to have to, really have a sensitivity specificity to handle
The current feeling on that is that so until now, it's always been necessary to find a trypanosome under a microscope to have a positive
yeah.
diagnosis because of the complications around the drugs, and you also had to do a lumbar puncture to find parasites or elevated white blood cells in CSF to know that you need to go for a complicated or dangerous stage 2 treatment. Acoziborol, when it comes along, is probably so safe and so easily to administer that even if the lateral flow tests, I mean, they're definitely nowhere near as sensitive as a parasite diagnosis. We do know that the positive predictive value in diminishing numbers of cases becomes really, really poor. But even a very poor test or a relatively poor test, enough to give you a suspicion. We don't care about the false positives anymore because we're not going to be giving anybody anything toxic. We're going to be giving them a very safe drug. They can get it on an outpatient basis. You don't have to worry about that anymore. So the thinking at the moment is that the safety, particularly for acoziborol, when it comes along, and the simplicity of administration, a test which can be very, very quick, very, very easy, even if it's not very, very accurate, doesn't matter. You can probably capture, if you like, all of the true positives, and you're not going to poison any of the false positives, and actually the greater public benefit from being able to just sort of march through areas and really get rid of all of the trypanosomes from an area is too good an opportunity to miss. I hope there'll have to be trials to see how well that works out, but that's current thinking.
Yeah, I liked your section where you kind of looked at this and had this whole discussion. So
And I think it's an open access article, so we're going to link to it in the show notes. So it's very readable, so you don't need to be a scientist to be able to understand it. I think it's very, very readable. So if you have a chance, then you should go and read it. Look it up on the show notes. So shall we do our hero then?
Yes.
anyone, any last minutes? Mike Dixon, you good? We're ready for our hero? All right. Fantastic so far, Mike. So expectations are held high.
Well, it's really my fault. I kind of thought I wanted to choose a hero that I know. I thought we're going to make Mike work really, really hard tonight.
I must say this, at every ASP meeting I went to, or every international meeting that I went to, I hung out with the Scots for two reasons. One is that they drank the same kind of whiskey I drank, and two, they would not stop telling stories, and the stories were remarkable. George Nelson was an exception; he was included, but for the most part, George Urquhart and company would hold forth, and everyone was glued to the chair. They wouldn't go anywhere. They wanted to hear the end. So it's all yours.
So David Livingstone, I believe you're familiar with him, Mike. You may have written a biography or something. Is this true?
Yeah, hold on. I have it here. I
Again,
don't
there's
know.
a biography which has the author. The first author is actually he's got the same
Yes.
name as you again.
Yes.
I,
So this is quite a detailed biography that our listeners can. It's also open access. I checked that so you can read it. But I think Mike has also a few years ago he has produced a really amazing resource. It's called the Scottish Encounter with Tropical Medicine. And for those of you who are looking on YouTube, you can have a wee look at it. I'm not sure if it's actually sold anywhere. I
No.
have got a very precious copy that I'm not giving to anyone else. And so in this booklet, actually, Mike essentially gives a Scottish parasitologist timeline, of which David Livingstone is one. And so David Livingstone, I'll just start us off, and then I'll let you run, Mike. So he was actually born quite close to here near Glasgow in a town called Blantyre. Very close to here. I think he was born in 1813, and he was really born into quite poor circumstances. So he was actually working in the cotton mills on the banks of the Clyde. But he was really interested. He was a boy who liked to learn, and he did actually enroll to study medicine in Glasgow in a college that's called Anderson College. And I think that's probably where maybe I met Mike for the first time, in the Anderson College, because our labs, or my postdoc lab, was situated there. So yeah, it's kind of nice to reminisce on that as well. So Mike, do you want to tell us a little bit more about Livingstone? What happened
Uh,
to him? Why was he able to study medicine as a poor man?
well, the great thing about Scottish education was that, unlike English education in the 19th century, it was open to anybody who could pay a little bit of money. And what often happened in Scotland at the time is that if there was a child that showed interest in learning, then the local church would have a collection and raise enough money to enable those individuals to go and study. So, say Livingstone. When I became interested in Livingstone because I'm an Englishman, I came to Scotland to study tropical diseases, and people who've been to Scotland used to find that a little bit odd because it's not very tropical here at all. And I thought it was a very good question, and I just then wondered whether Dr. Livingstone, in particular, I'd heard about Dr. Livingstone as a child myself. He had a mythical status in the history of the United Kingdom. So I just found out a little bit about Livingstone, and actually, I probably a little bit um, inaccurate, but uh, Livingstone's story, I think, does explain a lot about how so many Scots made so many discoveries in tropical diseases. So Livingstone was born into poverty. I'd recommend anybody visit the David Livingstone Centre, which is the old mill house in Blantyre near Glasgow, which has now been turned into a museum of African exploration. His family grew up in a single room within this great big tenement block. I think 7 of them squeezed into a single room. You've got these beds which sort of tuck away underneath other beds, and it was pretty uncomfortable. He would wake up at 6 o'clock in the morning and go and work in the mill. His job was to pick up little pieces of cotton which were falling from the machines and to recycle them. Uh, Mill work would go on from 6 in the morning till 8 in the evening. He would then go to school for 2 hours till 10 at night. After school, he would come home and he would read Latin and botany, and became increasingly interested in science. But his father refused to let him become a scientist because he thought science was really contradictory to uh, a Christian God's will. However, Livingstone persuaded his father he could become a medical missionary and spread the gospel. He was going to go to China, but the Opium Wars prevented that. Then he met a chap called Robert Moffat, who had his own missionary in Southern Africa and South Africa, and Moffat persuaded Livingstone he should go to Africa, which he did. And he was a terrible preacher. He didn't convert anybody, but he was a fantastic scientist, I think, more than anything. And he was thoroughly interested in everything around him. So in his first trip to South Africa, he uh, took himself off out of South Africa up into across the Kalahari Desert to Lake Ngami, uh, for which he was given credit of discovering and became a little bit famous for having done so. Um, he got attacked by a lion, and while he was recovering from the lion attack, Robert Moffat's daughter Mary nursed him, and they ended up getting married. Um, they very quickly began to have children. Livingstone had his great desire to continue exploring and kept heading off initially took his wife and kids with him, but it was incredibly difficult to travel in Africa at that time. And I think he lost one daughter. His parents-in-law were pretty unhappy with that. And eventually Mary went back to Scotland. She'd been born actually in Africa and found it terrible coming back to the dark, damp environment of Scotland. Livingstone, during those expeditions, actually walked from Central Africa over to Luanda in Angola. He was looking for a waterway into Central Africa. He believed that if Europeans could come into Africa to join Africans to farm together, they would be able to do fantastic things. Unfortunately, the walk from Central to West Africa in Angola was so malarious, he didn't think that would work out. He'd taken a lot of Bakwain Africans with him, and he'd promised Chief Sechele that he would take them back, and he did. So he walked all the way back to Central Africa, and from there, having found that there was no good waterway in from the west, he thought he'd go to the east. So he walked following the Zambezi all the way to the coast in Mozambique, and en route came across things like the Victoria Falls, which he named after Queen Victoria. It's always a little bit ironic. He didn't really discover them. His African companions showed him where their local waterfalls were. And however, the other great thing about Livingstone was, well, he survived. He survived, I think, because of his medical training. He'd heard that quinine could protect you from the African fever that took everybody else out. So he developed a quinine-based remedy called the Livingstone Rouser, which was based on a certain number of grains of quinine. He also put rhubarb and jalap because he thought regular bowel movements were the best way of avoiding malaria. A little bit of opium to encourage people to take it. And he survived. He made other incredible discoveries. He was very open-minded. He worked with local medical workers to try and understand some of their remedies. He didn't just dismiss them. He exchanged ideas on what could be a good remedy. He discovered that the tampan tick was responsible for the transmission of relapsing fever, which we now know to be caused by Borrelia bacteria. He came really close, I think, to seeing the connection between mosquitoes and malaria. He wrote very frequently about the abundance of mosquitoes wherever you got malaria, but in the end he went for the old miasma theory that it was breathing swamp air that was responsible. So he really was a great observational physician, and his brilliant writer. So he came back to the UK, wrote a book called Missionary Travels that really brought to life the life in Africa, the wild animals, the people who lived there, the diseases. He wrote a lot about parasites. He dissected zebras and found these sort of red worms throughout their lungs, and elephants, and you name it, he would find parasites in them. Livingstone became incredibly famous based on his writings, and he also discovered that with that fame and also his abhorrence of the slave trade, he was able to have an impact on shifting public opinion in the UK on slavery. And he actually became obsessed with slavery and beating slavery. And he came back to Africa on a second expedition, having figured that the Zambezi was the way that Europeans could come in to start commerce and working with Africans. Unfortunately, although actually the Zambezi expedition was incredibly successful scientifically, brilliant work was done, it ultimately was considered to be a fiasco because they couldn't navigate the Zambezi. The Quebrabassa Falls rapids prevented that from happening. The other thing, he'd inspired so many people that missionaries and explorers began to pour into Africa, and many of them died of malaria. and he hadn't really articulated the importance of antimalarials. So by the time the Zambezi expedition had finished, Livingstone was now considered to be a bit of a villain. He hadn't done what he said he would do, and his fame began to wane. He, however, remained determined to attack the slave trade, which was actually getting worse and worse within Africa at that time. Also, the European exploration of Africa had really begun to focus itself around this biblical quest to find the source of the Nile, the river of the Bible. And a lot of other explorers like Burton and Speke and um, uh, others had started to compete really to find the source of the Nile. And Livingstone thought that only he was good enough to really get there. So he went for a third expedition to Africa. This time he didn't take any European companions. He couldn't get on with Europeans. He met up with a few of his old African companions, and he began to walk around the Central African watersheds looking for the source of the Nile. And during this time, various things went wrong again. His scientific instruments broke. He didn't really know where he was most of the time. He was convinced that Lake Bangweulu in northern Zambia was the source. It's not. He was beginning to look at the Congo, and eventually he got so many diseases. He had malaria, which he documents very well, scores of times. He had amoebic dysentery. He probably, I think, had massive schistosome infections. And he was becoming skeletal, and eventually, sadly, well, actually, before his death, of course, he was nearly dead when he got to the shores of Lake Tanganyika, and this is when Stanley, the journalist, had been sent out by the New York Herald to find Livingstone. And Stanley came very, very well equipped, and he did find Livingstone in Ujiji on the shores of Lake Tanganyika, and with the famous phrase, "Dr. Livingstone, I presume," introduced himself, and they actually got on extremely well for the months that they spent together there. Eventually, Stanley left and came back to the UK. Livingstone refused to go with him. He believed his work was not complete until he got to the source of the Nile. He went off traipsing around again and eventually got so sick he couldn't walk anymore. His African companions built a makeshift shack for him, laid him down there, and eventually he died. His companions decided that they should take his body back to where he came from and started a 1,000-mile walk with his body, which they'd preserved in alcohol and wrapped in tar-covered blankets, and actually took him 1,000 miles from Lake Bangweulu region in Zambia to the coast in Tanzania. His body was then taken to Zanzibar, and from Zanzibar it eventually came back to England. And although his body was very degraded by this time, his broken arm from the lion attack in his early years was enough to say who he was. And he got buried in Westminster Abbey. And I think really he was a good guy, and the slave trade was abolished in East Africa when he died. And there's no question, I think, that Livingstone played a huge role in the abolition of slavery in Africa. Some would say that there's a rather cynical play by the British authorities to use Livingstone as this saintly figure behind whom they could then go looking for perhaps less good colonial aspirations, and really the British would then use the the idea that Livingstone was this person who'd gone with this great civilizing mission to Africa, and that would be what the British would say that they were doing when they went there. And there was a very, very cynical use of Livingstone's name to try to um, justify the British adventures into colonial Africa. Livingstone's reputation took a bit of a dive because I think as people became conscious of some of the worst aspects of colonialism, his association with it made him appear to be a bad guy. But actually, I think in more recent years, as more of the histories are known, I think that role that he played in the abolition of the slave trade and the fact that he didn't use his own name, it was people after him who used his name as a sort of front for colonialism. He's been largely rehabilitated. My interest in him was really perhaps from the tropical diseases aspect, and it's just reading his books. The Livingstone's rousers and the use of quinine and the systematic use of quinine, and he found horses with trypanosomiasis and gave them arsenic, and that led to really the first steps in chemotherapy against trypanosomiasis. He was the first person to detect that tampan ticks are responsible for the as vectors of relapsing fever. So he just made incredible discoveries, I think, way ahead of his time, and was able to write about them because he had a gift for writing. So that's Dr. Livingstone.
Thank
Well, that
you.
was fantastic.
Yeah.
I feel like I've got to read your history as well. So fantastic.
And maybe even Dr. Livingstone's book.
Yes.
When I was on our little trek 2 years ago in Zimbabwe, a historian offered us, all 12 of us, his own view of Dr. Livingstone because we were at Victoria Falls at the point. And the rumor was that he died of malaria, but he actually didn't die of malaria. He died of hemorrhoids.
Yep.
And that is an ignominious death. I mean, that almost sounds funny, but it's not funny at all. If you've ever had hemorrhoids, you know damn well it's not funny. But imagine all of the modern conveniences of sanitation and medications like stool softeners, etc., totally unavailable. And he was stuck in the middle of all of that and
He had
endured.
he had an opportunity to have his hemorrhoids removed in Scotland before that final expedition, but he refused to do it because he didn't want the newspapers to hear that the great Dr. Livingstone had a hemorrhoids problem.
Exactly. And look,
Yeah.
I mean, it's
Humanity
just,
was the end of him, right?
no pun intended.
Mhm. So was it they got infected? He bled out. How did he die from the hemorrhoids? Do we know?
Yeah, they were bleeding hemorrhoids. So they said.
Yeah.
So they said. I don't know.
No, you just read so Livingstone's last journals. So he wrote his missionary travels. He wrote up the Zambezi expedition, and then Horace Waller got his. The guy was just writing. He would write on his Bible he'd keep his diary in the margins of his Bible. He would write on
Right.
anything that he could,
Yes.
and one of his later colleagues collected all of those and put them together into Livingstone's last journals. And at the end, it's a tragedy. He said, he talks about those last days when he can still write, and he says there's a constant stream of blood falling from me. And actually, when he died, his companions performed an autopsy on him. His spleen. Some people think there may have been a stomach cancer. He had this sort of gigantic spleen, which may have been malaria, may have been schisto. He loved swimming. He was always jumping into Lake Malawi and in Lake Bangweolo and the swamplands at the end. I mean, that guy must have had thousands of cercari penetrating his legs every day, I think.
Wow.
But yeah, he was skeletal at the end. He was just a walking skeleton because for those last months he had a constant flow of blood.
Hmm.
It's a And actually, there's famously, when he did die, his companions found him, and the suggestion is he'd got out of bed and was sort of praying on his bed. But if you read some of his things, I just wonder whether the agony that his intestines were giving him, that was as close to a comfortable position as he could find himself in at that time.
Wow.
Wow.
Mm.
All
On
right.
that
So
sad
on that
note,
note, yes. On that sad note, that's TWiP 238. You can find the show notes at microbe.tv/TWiP. Send your questions or comments to twip@microbe.tv. And if you like our work or you want us to just keep doing it, please consider supporting us. Microbe.tv/contribute. We would like to thank our guest today. Thank you for joining us, Mike.
It's a true
thank you,
pleasure.
Mike.
Thank you.
It's
Okay, I
really nice
look
having you
forward
on.
to hanging out with you again next time I'm in Glasgow. And as Christina suggests, maybe I will just come over for fun. Maybe I won't come over for work this time.
And we'll go to
But it's
Blantyre as
never,
well.
never work, never work. Dixon Des Pommiers, you can find him at trichinella.org, thelivingliver.org, parasiteswithoutborders.com. Thank you, Dixon.
Fantastic. Thank you, Daniel, and thank you all of you wonderful Glaswegians for sharing your history and your lives with us.
All right. So Christina Nalla is at the University of Glasgow.
Thanks for a fun evening. I really enjoyed having Mike on the show and having conversations with Dixon and Daniel.
All right. We would like to thank the American Society for Microbiology for their support of TWiP and Ronald Jenkins for the music. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back in 2 weeks. And Mike, you get to read the last line.
Thank you very much.
He doesn't, have,
sorry.
he doesn't have to show
You get to
notes.
read another. Well, no, this is all good. So you're going to get to read Another TWiP is Parasitic. Are you ready to go, Mike? Whenever you are, take it away.
Another TWiP is parasitic.